Hey people, notes 3.1 are on slope, and this is a continuation of what we did in class. So we're going to skip through page 3 and we're going to move on to page 4 of our notes right here.
Okay, so on page 8, let's take a look at the first question that we have. It asks us to find the slope of each line. So if you remember in class, we learned a bunch of different ways to find the slope. When we have a graph, the best way to do this is by doing rise over run. And remember, the letter for slope is m. So we can either do rise over run, or we could do change in y over change in x. Those are interchangeable. They're saying the same exact thing, okay? So I'm going to choose 2 points on my line. Now be really careful about the 2 points that you choose. I wouldn't want to choose this point, for example, because if you asked me to tell you what it is as a coordinate, I couldn't tell you exactly what it is. I know it's somewhere between 2 and 3, but I don't know if it's exactly 2.5. So that's not a coordinate that I know exactly what it is. I'm going to choose this coordinate right here because I know it's exactly at 2, 1. It's a coordinate I can tell you exactly what it is without approximating. And I want to find another coordinate that I can do the same thing for. So I can look at this coordinate right here, and I know exactly that that is at 4, 5. So what I'm going to do is I'm going to draw in my slope triangle. So I'm going to figure out what my rise is and what my run is. Now be very careful about your signs. So here I can say my rise, it went up by 1, 2, 3, 4. So since it went up, it's a positive 4. So my rise is positive 4. And then my run, it went to the right by 2. Since it's to the right, it's a positive 2. So it's positive 4 over positive 2. And when I divide that out, I get positive 2. So that means my slope is 2. Now looking at my graph, I should see, does my answer seem to make sense? Does it have a positive slope? Well, when I look at it from left to right, it looks like it's going up. So it definitely looks like it has a positive slope. Okay? Now that's not the only way that you can do it. So I could start right here and I could end right here instead. And I want to see if I'm going to get the same answer. Remember, we just talked about the fact that it doesn't matter how long your segment is, it's still going to give you the same slope. But let's just double check. So rise over run, this time my graph only went up by 2. So since it went up, I'm going to say it's a positive 2. And then since it went to the right by 1, I'm going to say the run is 1. So it's 2 over 1, which is 2. So that therefore my slope is still 2. Nothing's changed. Well, I want to show you one last example. What if instead I decided to start at the rightmost point and go to the leftmost point? Let's see what this is going to tell us right here. So I'm going to draw in my slope triangle, and this time my rise is going down by 4 instead of up by 4. So I'm going to say it's a negative 4. And then my run is going to the left by 2. So since it's left by 2, I can say it's a negative 2. But when I divide my double negatives out, it still gives me a positive 2. So no matter where you start and where you end, you should always get the same answer. Okay, so let's take a look at this next example. Here it gives you your starting and your ending points. We're going to do rise over run or change in y over change in x. I'm going to use change in y over change in x this time so that we can see that it's the same thing and that they're interchangeable. I'm going to draw in my slope triangle. So here's my triangle. Remember, my sides need to be either vertical or horizontal. This went down by 3, so I'm going to say that this has a rise of negative 3. So I'm going to say my answer is negative 3 for my rise, or my change in y. This went to the right by 4, so it's a positive 4. So therefore, my slope is going to be a negative 3/4. Now, you have a couple options. You can either make the 3 negative, or you could have the 4 be negative like this, or you could just put the negative sign in front of the whole fraction. But make sure that you don't have a double negative, because the double negatives will cancel out to become positive, and your graph will look like this, as opposed to what we have in question number 2. All right, so taking a look at number 3, we have a horizontal line. And if we have a horizontal line, we should know what the slope is, but let's just show the workout for it so we can see how this works in this example. So we're going to do rise over run again. So here's where it starts and here's where it ends, and it doesn't go up at all. So my rise right here is 0. It's staying flat. It's not moving at all. But it ran by 1, 2, 3, 4 to the right, or you could say 4 to the left. It's up to you, whatever you prefer as your starting and ending point. So I'm going to go from left to right and say it's positive 4. 0 divided by 4 is 0. And we should get that our slope is 0 because the slope of every horizontal line is always going to be 0. Okay? And then our last example here is the tricky one. So we're going to do rise over run again. So m equals rise over run. And this time I'm going to say that it rose by 1, 2, 3, 4. So it went up by 4, so it's a positive 4. But it didn't go over at all, so it's going to be 0. So 4 over 0, what do I get when I divide 4 by 0? Let's try it in our calculator and see what we get. 4 divided by 0, you get an error message telling you you cannot divide by 0. So this is impossible. Since it's impossible, we say it's an undefined slope. Okay, so now question number 5, when will the slope of a line be positive? So how do we know when a slope of a line is going to be positive? Well, we know it looks like this. So this is our positive slope. And this will only happen when our rise and our run have the same sign. And the reason why that works is because if this goes up, it has to go to the right. Or if I say it goes down to the left, then it has to go, if I say it goes down, then it has to go to the left. So they're either both positives or they're both negatives, but they'll cancel each other out to become positive. Okay? And then if the slope is negative right here, so here's the slope that's negative, this is going to tell us that the rise and the run have opposite signs. Okay, so let's take a look at this example. This went down and to the right, so here my signs are opposite. Or I could say it goes up and to the left. If it goes up, it's positive. If it goes to the left, it's negative. So they still have opposite signs. Okay, so now question number 6. Determine the slope of a line that passes through the points 2, -5 and 7, -10. This is a little bit harder, but once you actually get used to just plugging in your information, it's not so bad. So remember, we also talked in class about how the formula for slope is going to be y2 minus y1 over x2 minus x1. Okay, so in this example right here, let me actually color code this so you can see it a little bit better. So we'll say y2 right here minus y1 over x2 minus x1. When I look at my point right here, this 2 that I have right here is my first x value. So we call this x1 because it's my first x value. Since that one's my first x value, then this -5 has to be my first y value. So I have to call this y1. Okay? Then when I take a look at this coordinate, I realize that this is the second x value, so we'll call this x2. And then since this is my second coordinate, this is going to be called y2. So now let's go ahead and plug in our information right here. So instead of y2, I know that y2 is now -10. So every time I see a y2, I'm going to replace it with -10. Minus, instead of y1, I know y1 is -5, so I'm going to replace it with -5. And then in my denominator, I know that this x2 right here, we figured out is 7, so I'm going to say 7, and then I have a minus sign, and then right here, my x1 value is 2. Now be really careful about this, because a lot of people up here will see this minus and think, well, I don't have to put the negative sign in front of the 5, but that's crucial to put it in there, because now what this ends up being is minus a negative, which really turns into a positive. So this ends up being -10 plus 5 over 7 minus 2. So I get -5 over 5, which is -1. Therefore, my slope of my line that passes through these 2 points is -1. Okay, let's go ahead and do the next example together. So here, this -5 is my first x value, so we'll call this x1. This 7 right here is my first y value, so we'll call this y1. The -5 in this example here is my second x value, so we'll call this x2. And then this 9 is my second y value, so we'll call this y2. So let's go ahead and write out the formula. So m equals, we know it's y2 minus y1. And I want you to rewrite the formula every time so that way it gets stuck in your head. Over x2 minus, and then we've got x1 right here. Okay, so then we end up getting equals. Now let's fill in our information right here. We know there's going to be a minus sign in between both sets of numbers in our numerator and our denominator. So in our numerator, I'm going to say 9 because that's what y2 is, minus y1. I look for y1, I know it's a 7. And then in my denominator, I know my x2 is negative 5. And I know that x1 right here, when I look at what I labeled it, is negative 5 as well. Don't forget, this minus a negative turns into a positive. So I end up getting 9 minus 7 over negative 5 plus 5, which means I get 2 over 0, which is impossible. We already figured out you can't divide by 0. So therefore, the slope of my line is going to be something called undefined because we can't divide by 0. It's impossible. Therefore, my line is going to be a vertical line because all vertical lines have undefined slopes. And if I were to draw a quick sketch of what this looks like, if I were to go to negative 5 on the x-axis and 7 on the y-axis and put a point there, and also put a negative 5 on the x-axis and 9 on the y-axis and put a point there and connect my dots, I'll see, oh, definitely we'll get a vertical line. Okay? Number 8, we're going to discuss next time I see you guys in class. I hope you have a great day. See ya.